Alright, so I had a request to do number 58. 58 starts you on the uniformal circular motion. As I told you guys, this one's the hard part. It's not hard to solve it, it's hard because you have to be able to think about it. You have a lot of thought process that goes into this. So number 58 reads, a 615 kilogram racing car completes one lap in a time of 14.3 seconds around a circular track that has a radius of 50 meters. Assume the race car moves at a constant speed. Part A, what is the acceleration of the car? And part B, what force must the track exert on the tires to produce this acceleration? So here's the information we have from the problem. I got mass here for 615 kilograms. I have time at 14.3 seconds. I have radius at 50 meters. We're trying to find acceleration and we're trying to find the force. So you need to think about what's going on. Before you even get started on trying to work any one of these problems, you need to think about the situation you're given. So this is what you're given. You have a track. It goes around in a circle with a radius of 50 meters. You have a race car driver that drives around it, and he makes a lap in a time of 14.3 seconds. So the car is actually driving on the blue here, where the circle is. And it takes him, if he leaves from this point, to go all the way around and get back to the same point. It takes him 14.3 seconds. You need to find the acceleration. So part A of this, we need acceleration. So, how can we do that? What is the centripetal acceleration formula? Equals velocity squared divided by the radius. I know the radius, I don't know velocity. You need to come up with a way to find it. This is the part where you have to think. How can you find it? What is velocity? Velocity is equal to change in position over change in time. I have time, but I need position. 50 meters is not your position. 50 meters is a piece of information given for you to find your position, the change in position. Here's what you're going to need. You're dealing with a circle. This, if you go all the way around, that's your circumference. You're going to need circumference of the circle. Once you find the circumference, then you have the change in position. So, to find your circumference of a circle is equal to 2 pi r. So 2 times pi times 50 meters, which will end up giving you let's go 100 times pi. So I get 314.1593 meters. Now for this I actually punched the pi button on my calculator, so if you use 3.14 or 22 over 7 and it's a little difference, that's why. I made for sure to use the pi that's on my calculator. So now I can go back and solve for the velocity, because this is my change in position, the circumference. So change in position, 314.1593 meters divided by time, which change in time is 14.3 seconds, which will be equal to, get it over here, 21.9692 meters per second. I'm still not done. Only thing I've got there is velocity. And if you didn't come up with this exact number with these decimals, it's because I keep, like I told you guys in class before, I don't retype this in. I store those numbers in my calculator for accuracy in my calculations. So let's go back. Let's do the acceleration now because I have everything I need for it. I have the velocity and I also have the radius. So I can find my acceleration to be equal to the velocity squared divided by the radius, which is equal to 21.9692 meters per second. And that whole quantity is squared divided by the radius, and the radius is 50 meters. So we'll find that. Remember, like I told you guys, I'm just storing that number in my calculator that I squared there for that velocity I solved for. I get 482.6448433. And then I'm going to use that number and I'm just going to divide by 50 to get me 9.6529 meters per second squared. There's my answer to part A. So I have the answer to part A. Now the question's being asked in part B. So part A, what is the acceleration of the car? Part B, what force must the track exert on the tires to produce this acceleration? So we're looking for the force. And the force off this centripetal force is just like what we've saw before with force equals mass times acceleration. So what we're going to do, I'm going to do it in blue. Let's do part B. I'm going to do it right here because it shouldn't be that long of a problem. Force is equal to acceleration, well, mass times centripetal acceleration. So centripetal force equals mass times the centripetal acceleration. So mass, I was given to be 615 kilograms. That's good because I'm going to end up in newtons, so kilograms times meters over second squared. So the centripetal acceleration, which we solved for from part A, times 9.6529 meters per second squared will be equal to, so I take my calculator, multiply this out really fast, 615. So it'll be equal to 5,936.5316 newtons. There we go. Nice little problem there. So we ended up with 5,936.5316 newtons. Now with this little thing added with there, all you that were saying you were missing forces, well, forces are coming back into it now. It all interacts together. Remember what I told you guys, it's just a lot of thinking. It's a lot of thought process that goes behind it. All you had to do was think about this circumference. And I know it's not obvious. It's not always obvious. You just need to take time, stay calm, and start picking and choosing and make for sure you're understanding what's happening in the problems you're given. If you guys got any more questions, shoot me a message on Remind. I'll try and help you as much as I can. If not, I'll see you tomorrow.